Wait. Don't dislike just yet. I've made a few tests, and it's pretty interesting. Hi, welcome to my channel. My name is Lucian, but you can call me Lucian if you want. Today we're going to take a look at the loops inside loops performance, or as we like to call them, 4 in 4. And watch until the end, because I want you to challenge me. As Salesforce developers, we were taught that loops inside loops are generally a bad idea, and we should avoid them if we don't want to hit the CPU time governor limit. But how bad are they, and are they always bad? Let's consider a simple and unrealistic requirement, where we have to write a method that receives a set of account IDs and will return a map. The map should have the account name as key and the list of contact emails as value. Let me show you what I believe is the most efficient way to implement this. I have a new class here, and I'm going to write a static method called getEmails1. Like I said, the class receives a set of IDs and is supposed to return a map. I would implement it using a single query from the contact object, where I also extract the name from the related account. The recommended way is to put the query inside the for statement, because this way Salesforce will optimize the data extraction and you can avoid hitting the heap size limit. Inside the for loop, I check if the map already contains the account name as a key, and if not, I add it. Then I simply add the email address to the correct list in the map. Finally, I return the list. But I want to calculate the efficiency of the 4 in 4 algorithm, not the data extraction methods. So for the sake of testing, I'll separate the query from the logic. Now I can add 2 lines of code to measure CPU time before and after the logic, and afterwards I will display the difference in a debug statement. I've pre-populated this org with about 200 accounts, and for each account 5 contacts, so we're basically working with about 1200 records. I'm writing a quick anonymous Apex piece of code where I extract the first 200 accounts to gather the IDs, and I will test by passing the set of IDs to my method. After running it, I open the log and check the debug. Okay, 50 milliseconds. Not bad. I don't want to be influenced by a single test anomaly, so I ran it 9 more times, and it looks like we get pretty consistent results. The average is 50 milliseconds. Let's now imagine that we are new to Salesforce, we don't know much about SOQL, and we want to write this requirement. Let's call this method getEmails2. I'm going to extract the data using 2 different queries. One to get the name of the account by the account IDs, and one to get the email of the contact, filtering by the account ID field. Next, I'm going through all the accounts using a for statement. I initialize a list of emails, after which I go through all the contacts in a second for statement and verify if the current contact is linked to the current account. Then add it to the email list. After the second for statement, I put the created list in the map. Finally, I return the map. I know you cringe seeing my code now, but it's for science. In order to test, just like before, I'm measuring the time that passes and show it with a debug statement. Let's run the same anonymous code as before, but change to use the second method. This is already not looking good. It took long enough. So let's open the debug log and see the result. Wow, more than 5 seconds of CPU time. That is 100 times more than our previous implementation and half of the entire CPU time limit. Of course, I ran it 9 times more just to be sure, and the results are consistently bad. Like real bad. I didn't expect it to be 100 times more inefficient. And the scary part is that this piece of code can be hidden in a huge org with 10,000 lines of code, and it will be pretty hard to find and debug. Okay, so 4 in 4 can be really bad, but is it always bad? Let me show you another piece of code. I'm going to duplicate the getEmails2 method and name it getEmails3. But this time I've just learned about subqueries, so I'll update the accounts query to contain a related contact subquery. Then in the second for statement, I'm going through the contacts related to the account. So we don't need this if condition anymore. With this change done, let's run the code again. Okay, 118 milliseconds. Could this be an error? Nope, it's consistent. We use 4in4 in both versions, so why is this version much better than the previous one and even comparable with the first version, which has a single 4? Well, let me show you something. In the first 4in4 version, we go through all the accounts, and for each account we go through all the contacts. Since there are 200 accounts and 1000 contacts, we go through the if statement 200,000 times. Even if we pass that if statement only 1000 times, checking that condition adds up a huge amount to the CPU time. We're basically working through a huge matrix. In the second 4in4 version, we only go to the relevant contacts for each account. So we are now working with a tree structure instead of a matrix. The first line inside the second 4 is only reached 1000 times, similar to the single 4 version. I do consider that the difference between a single 4 version and the tree 4in4 version is small enough to consider using the latter when it makes sense. Sometimes a single 4 version will require creating maps, which can add to the CPU time or even the heap size limit. Use your judgment there, and use the limits class to actually test the efficiency of your code. So my conclusion, try to use a single loop as often as possible. If it makes sense to add a second loop, make sure it goes through a tree structure. And definitely avoid using 4in4 to go through a matrix, unless of course the requirement is to generate a matrix. Okay, challenge time. Not for you, but for me. I want you to challenge me to do a code optimization. Tell me a situation where you could not avoid the bad version of 4in4 and I'll try to optimize it in a future video. If I fail to do that, I'll do a shame dance. Put your comments below, subscribe to my channel, follow me on Twitter, LinkedIn, what have you, and I'll see you on the next video. Thank you for watching and get coding.